Now, thank you very, very much for this opportunity to talk to you at the LNG conference. It's quite a big difference from previous year, but hopefully, yeah, we can tell you a very interesting story about developments in LNG. And what a year it has been, because a lot of things have changed. And one of the things you can see on the picture, for instance, is one of the largest working ships in the Netherlands, operated by Heijden, which is actually running on LNG at the moment. So a lot of things have been going on. Okay. But let's go one step back. The reason why we have to do this presentation as we do it offline, online, is because of the COVID-19. And there are quite a lot of similarities between the developments in LNG and in COVID-19. A lot of companies where countries have their own approach to it, sometimes successful, especially Korea, sometimes a little bit less successful, like in Europe. But I think if we work together, we can achieve a lot more and a lot quicker. And that's very similar to the developments in LNG. Now, if we look at TNO, who is TNO? Now, we are the largest research institute in the Netherlands. We have about 3,500 technical experts, 45 different laboratories, and still counting. We are still developing new laboratories. We build them, we take them apart if we no longer need them. And that's something we already do since 1932, or certainly, yeah, 1932. 80% of all the projects we do are with industrial partners. So we very much work together with companies that can be in Korea, that can be in the Netherlands, can be in Europe. For instance, the developments Hyundai Motors has on autonomous driving is actually done together with TNO in the Netherlands. Now, a lot of developments we are doing actually in Europe are coming from what we call the Green Deal. So we look at how can we reduce the CO2 emissions and NOx emissions. And we did not do this just by ourselves. We do this in a European way. So we work together. And we don't just look at the ship or just look at the supply chain. We also look at the whole infrastructure. Okay, how can we do it? What kind of fuels are, let's say, very attractive? And we already know that it's not always LNG who is the most attractive one, although a lot of people think hydrogen is the most attractive one. Also, that is not the case. So we pretty much look at the entire supply chain. What we do in that case, we look from what we call well to wheel or well to wave. And in this case, we look at CO2 reduction. So we look at the carbon intensity of the energy carrier, how efficient is it, how much is the energy density, how it is transported, how it is made, how it can be stored. And storage doesn't mean always on board of the ship, but also means how it is transported, where does it come from. So we also look at the entire, let's say, the chain and see which one is most efficient. Now, similar we also do for NOx, we also do it with fine dust. And is, for instance, hydrogen always the perfect fuel for all solutions? No, we don't think so. And a lot of people think actually the same way. We had a bit of a look at all the hydrogen reports over the years, and we see, and this is an example of the predictions, and you see it varies widely. We looked a little bit more on why does it vary so widely. There's a lot of challenges. The first one actually is green versus gray or blue hydrogen, the energy efficiency, and also whether you include CO2 capture or CO2 usage or not. So of course, it might seem that hydrogen and LNG are actually competitors. I think they are not, because they both can coexist quite happily next to each other. LNG is a very good fuel for a lot of application, especially in the maritime industry. Now let's look at some of the research topics we have done at TNO over the last couple of years. And we always try to be innovative, economic, and safe, because we do think that yes, you should try to be as environmentally friendly as possible, but it should be economically feasible as well. Now, the first step, what we did was actually we looked, okay, which fuel is attractive for which type of vessel? And we looked at ferries, cruise vessels, container vessels, general cargo, and all have their typical behavior, their typical fuel consumptions. And for instance, for LNG, ferries are not so attractive because they always go from a fixed point to a fixed point. So they can either be electrically operated or even hydrogen. But the container, the cargo vessels, and the cruise vessels, their LNG is indeed a very attractive fuel. And we do see it really as a fuel which can bring the emissions much closer to where they have to be. But there are some challenges. Now, some of the challenges also on LNG is, okay, how can we store the LNG on board? The amount of space we need is actually quite a lot. So that ideally we would like to use the empty spaces on board of a ship, for instance, on the side of the hull. But that also means that we have to look carefully again at crashworthiness of ships. Now here you see actually the video, you see the crash test we have done a couple of years ago. You also see the crash test of an LNG tank in our lab under cryogenic conditions. And we said, okay, yes, if you do it correctly, it is possible to use these empty spaces to store LNG. One of the criteria is, of course, that the tank should be can be damaged, but it should not rupture. So it can be deformed, but it should stay actually in one piece. And there are now a few actually ships which already have this new tank actually on board. Another option is actually what, for instance, GTT in France has done. They are using the space underneath the wheelhouse as a storage for LNG, which is another very good way of doing it. And that actually is also one of the advantages of LNG, because what we try to achieve that storing LNG on board of a ship is as safe as the heavy fuels or diesel. And that is something we call equivalent safety. So a newer development is actually the CO2 capture. LNG as a fuel still actually emits CO2, but there is a possibility to capture that CO2 and to store it on board. This is a project we are doing together with Wärtsilä and a few other companies to actually have a ship where we do this CO2 capture. Within TNO, we already have quite a lot of experience with capturing CO2 in the industry, both on power plants, but also industrial processes where we actually capture the CO2. And one of the things why CO2 capture on board of an LNG ship is very attractive is because of the energy consumption and availability of heat and cold on board. For instance, when we evaporate the LNG, we need a lot of heat, and we can use that actually to liquefy the CO2. The exhaust gases we can actually use to create ammonia. So actually, we already have these heat and cold sources available on board of a ship. So energy-wise, actually CO2 capture is fairly easy to do. It does mean, however, that you need an additional tank on board to capture the CO2. However, CO2 is far more safe to store than, for instance, LNG. So it's much easier to do, although it is under, let's say, reasonably cold conditions and pressure. The question, of course, then is, what can you do with the CO2 after you have stored it on board? Now, in Korea, you don't have the opportunity to store large quantities in empty oil fields or salt caverns. So one option actually is to reuse the CO2 for something else. Unfortunately, a lot of these opportunities to turn CO2 into something useful require hydrogen. And what you can see on the graph on the left, the orange part is actually what the product actually will do on the world market, and the blue graph will determines how much it actually will cost to produce. So you see already that there are just actually one, which is formic acids, which can be produced out of CO2 by adding of hydrogen, which is actually very cost effective. Now, another option is actually to do the same, but then with electrons, a different process. And there you also see that there are possibilities to turn CO2 into something useful again. Okay, this is not going to be done on board of a ship. It's going to be done on shore, but there's definitely an option to do something with the CO2 besides storage. Another part which still has to be done, although a lot of development have been done already on this one, is actually the development of all kinds of components. Also here at TNO, we have done quite a lot of work. The hoses, as you can see on the right-hand side, they have been developed at TNO. Together with, in this case, with Güteling, the TNO, we did develop the test procedures, what has to be done, how has to be tested. And there are a lot of opportunities, because if you just follow the rules and regulations, you don't always have the opportunity to develop new products. It does mean that sometimes you have to look very practical to it. So for instance, you see in the middle the picture of the truck running over a hose. Initially, the classification bureau, in this case Bureau Veritas, says, no, this will never happen, or it's not a part of the regulations. But we said, okay, this can happen, so we actually should test it. Now, another development are, for instance, the use of tanks, high pressure tanks, and for instance, with the sensor you see on the side of it, which is a fiber optical sensor, which you can actually incorporate with the tank, which then you can actually measure pressure continuously, and that means actually you can monitor the tank actually much better than you would be doing, let's say, with only, let's say, a pressure sensor or a temperature sensor. Another part of the development, of course, are the development of new materials and how do materials actually behave when they are exposed to LNG for a very long time. This also means that sometimes there will be a lot of testing required. Now, one of the systems we are actually developing at this moment together with KNR, Flutek, Safetia for Kyunghwa Technopark, and also Korean Registry is involved, is actually the LNG transfer system testbed. The idea is actually to test different transfer systems and to see how they would behave when, for instance, we simulate a ship-to-ship transfer. That means that on the right-hand side, you see a setup which you can actually mimic the behavior of the wave of the ship, of the two ships, the movements up to roughly 3 meters. And on the left-hand side, you see the transfer system. In this case, it's a fairly simple one with a hose, but it can be anything. Also, the couplings can be tested. And then actually that means for Korean companies, they can have a testing facility available in Korea where actually you can test your equipment. And this kind of equipment can also be used for training of ship crew or bunkering vessel crew to make sure that everything can be operated safely. We choose actually to operate not with LNG at this moment, but with liquid nitrogen. We find out that in nearly all cases, this is a very good substitute. And the reason why we choose N2 is because you want to test these systems to the limits. So you want to make sure that all decoupling, or for instance, the QC-DC is going automatically. So deliberately, we want things to go wrong in a test situation. So that's and then liquid nitrogen is actually a far better option than doing this with the real LNG. But the way of testing is actually exactly the same. Another part which we also have been involved with is actually looking at fire safety and also exposure to the environment. We deliberately put an LNG tank on fire to see, okay, how would this tank actually behave in case there was a fire. It was actually not so much to determine will the LNG tank withstand the fire. It was actually more for the rescue services to see how long is it safe to move in. And we find out that actually for about 1.5 hours is actually safe to tow the vessel to a safe location, even when it's on fire, or to evacuate the people. So in this case, I have to disappoint you a little bit because the tank actually did not explode. It only exploded when actually on a much smaller scale, we put the tank deliberately in the water. So it was cooling down really rapidly. And then, it exploded. Another thing which we still have to investigate, but we are planning to do that, and we do that together with our automotive department, is actually the combination between LNG and batteries. One of the things we found out, and that is also a general trend, that there are more and more hybrid vessels, and in that case you store lithium-ion batteries very close to the LNG tanks. And that is also something to, let's say, investigate still. Okay, how safe is it, and how can we make it more safe? Another part which we also look at is actually the impact on the environment. Let's say if something goes wrong, we want to know, okay, how is the impact actually, how is the impact on the environment? And on the picture you see, let's say, these circles. We did this for the harbor of Rotterdam. And here you can see actually an LNG transfer system located right next to an oil refinery, which of course was not such a good idea. But by making these circles and by calculating it, we actually could predict, okay, if something goes wrong, this is what could happen. And that's actually is a very good way of doing it, because you want to make absolutely sure it's safe. And of course, you hope it will never happen, but yeah, we have to look into the worst case scenario. So what are developments in LNG? Let's summarize it a bit. To make LNG more attractive, it should be actually possible to use the void areas in the ship to actually store it. That means new tanks and new type of tanks, new shape of tanks, but also to be able to relook at the crashworthiness of vehicles. Also, the onboard storage of CO2 is also something we have to consider, especially because this actually will strengthen the, let's say, the proposition of LNG for the future, and much further than we actually can do with the current use of scrubbers. Then I come also to the next one, actual carbon capture. Very efficient use of onboard energy, as we have seen. It is the next step in energy reduction, and it can be done. The technology is already available. It is used predominantly onshore at this moment, and we hope to have the first LNG ship with CO2 capture up and running by 2025. Of course, we still have to look at the CO2 usage, because that also will make CO2 capturing far more attractive. Component testing, as we have seen, testing of new components, new materials, new tank materials, but that also means that you have to look at the regulations. Not all materials, not all tanks are suitable at this moment or can be captured under the current regulations. That also means that we have to work with, for instance, Korean Registry in Korea or Bureau Veritas or DNVGL to see, okay, how can we make these new new tank materials possible for the regulations. System testing and safety, that is something that, let's say, we still have to do. testing of transfer systems we can already do in Korea. We hope to have that operational within the next few years in Korea. And then, of course, the safety analysis is something, we also, so we have a lot of experience with that as well. And we can work together also with the various companies in Korea. But it also means that we have to work together. It's not that one company like TNO can do everything by ourselves. We're also looking for companies in Korea, organizations in Korea who would like to work with us together to develop these new technologies. So thank you very much for for the opportunity to talk to you about the new developments in LNG. Actually, there are what we say oceans of opportunities in LNG. So I would challenge you whether you would like to join us in this, seeking out these opportunities and making this a reality. Thank you very much for your attention. And if you have any questions, please feel free to ask.